Hi friends, see, I think we have left over only one part in ray optics and optical instruments. For last video in part 6 we have completed up to, that is, devices like simple microscope and compound microscope. Now the only thing we have left over is reflecting telescopes. This is the last part, that is part 7. Okay, ray optics part 7 this is. So we are left over with reflecting telescopes, please. In before video we have completed refracting telescopes. One is, that is astronomical, another one is Galileo. Galileo is deleted from the syllabus. So in astronomical telescope I told you to observe the distant objects on the Earth's surface like stars, planets, moon, which are very far away from the Earth's surface. So those will come very nearly and clearly is observed by using telescopes. So in astronomical telescope you see it is an opposite of compound. A bigger lens is in the objective and smaller lens in the eyepiece. So there we observed different formulas like f0 by fe in normal adjustment for relaxed eyes, and in maximum magnifications f0 by fe into 1 plus fe by d, where d is 25 centimeters. So like that the magnification formula was extracted from the things. Now in reflecting we have only two cases, and these are not so important, and derivations are also not there for examinations. So reflecting lo manaki enti modadadi I'll write it here, Cassegrainian or Cassegrain telescope. Cassegrain or Cassegrainian telescope, this is called as reflecting. Okay, alage next one is Newton's or Newtonian telescope, please. Second one, these are the only two left over. Next one is Newtonian or Newton's, which was given by the scientist Sir Isaac Newton, famous scientist. Newtonian telescope. So these two are reflecting telescopes. Asali enduku kanipettavalsi vachindi, because in refracting telescopes there was some errors, like there are some errors. Entavi, like aberrations are coming, aberrations like spherical aberration, and chromatic aberrations, Spherical aberrations and emi ledu, images is forming at different points. For example, if you use convex lens, okay, you can see due to the marginal rays, these are marginal rays and these are paraxial rays. So marginal rays, you can see image will be forming somewhere over like this here, and paraxial at distance places. So you can see image, there is a disturbance of image I1 and I2. This circle is called as, that means image is confused whether this one or this one due to marginal and paraxial rays. I told you what is marginal rays, far away from principal axis, light rays. Very nearer to the principal axis is called as paraxial rays. So due to this effect, spherical aberrations are obtained. In the same way, chromatic, different colors, like Vibgyor colors. Okay, so different colors are forming some different images, and that is again, that defect also there in the refracting telescopes. So వాటిని సరిచేయడానికి కోసం మనం ఏం చేస్తామంటే ఈ రిఫ్లెక్టింగ్ టెలిస్కోప్స్ అనేది కనిపెట్టి, దీంట్లో పూర్తిగా 100% రెమెడీ లేదు, బట్ దెర్ ఈస్ ఓకే 100% there is no remedy. పూర్తిగా defects we cannot eradicate the defects, but somewhat defect is eradicated in these reflecting telescopes. So దాంట్లో ఫస్ట్ ది Cassegrainian or Cassegrain telescope. So this was invented by a scientist named Cassegrain. ఈయన ఏం చేశారంటే Cassegrainianలో, he has taken one concave paraboidal mirror. He has taken a concave paraboidal mirror. Okay, and of course this is the principal axis. Now this is the focus, and suppose the rays from infinity are coming, for example, Suppose rays from infinity are coming. We all know these will go through focus. These rays will go through focus. So here the image is formed. Now what is this scientists have done is, he has taken one more mirror, which is none other than convex mirror. ఏం చేశాడు ఆయన? ఇంకో మిర్రర్ తీసుకున్నాడు, కాన్వెక్స్ మిర్రర్. This is concave mirror. So what happened is, see, in this case, these two cases reflecting low, syllabus lo derivations levu meeku, only the explanation purpose is there. So that is where derivation I am not telling, only the explanation is there, because in the examination they may ask what is a Cassegrain telescope, why this was invented, who has invented, the scientist name, okay, like a Newtonian telescope, what are the things are there in Newtonian telescope, even adagochu. Now you can see, after falling on this one, what happens? It will reflect. After falling this rays on this, it will reflect. A small aperture is made here for this concave. Okay. So after reflecting, what happened here in this place? He arranged a small convex lens so that to make this rays parallel. After, and this is the observation eye. So this is the convex lens. Convex lens placed here, and after that meeting, it is going parallel. So somewhat the defect was rectified in this one, spherical and chromatic aberration. So in this fashion, the Cassegrain telescope is explained by the scientist Cassegrain. He has taken a paraboidal concave mirror and a convex mirror placed in this fashion. Okay. So after meeting parallel rays, infinity, it is meeting at this point, image forming at this focus. But what we do is, we will put an obstruction for this one not to come here, another convex mirror. So when it meets the convex surface, it reflects, and a small aperture is made here for the concave mirror, mirror 1, and these rays reflect and finally go parallel, and there is observation here, convex lens for the image formation. So this is about the Cassegrainian telescope. Now next one, second one and last one, that is Newton or Newtonian telescope. Newton or Newtonian telescope. Idento ఒకసారి చూద్దాం. This was invented by the scientist Sir Isaac Newton. So what he has done is, ఇక్కడ ఏం చేసింది ఏంటంటే, న్యూటోనియన్ టెలిస్కోప్ లో Newtonian telescope, here he has taken the same thing, paraboidal concave mirror, paraboidal, DAL. He has taken concave paraboidal mirror. Of course, this is the pole, principal axis, infinity rays, rays coming from infinity, again after meeting, going through focus. Okay, image is forming here. Now here what he has done is, with the vertical, Newton used a plane mirror. He used a plane mirror. This is a plane mirror, kept at an angle 45 degrees. Okay, this is a plane mirror. Okay, kept at 45 degrees. Okay, in front of the concave mirror. Now what happens after reflecting these light rays? It falls here. So normal. Again reflects down. Again this light rays falls here. Okay. Okay. So these light rays after falling here, ikkada normal or the end ikkada normal. Okay. So here if you draw a normal here, you can see this is a light, normal and perpendicular. Like a perpendicular. So light rays are reflected in this fashion after hitting, and here he arranged again a convex lens. Okay. Observation here, I. So this is a convex lens again. Convex lens. Okay. After hitting the light ray, it is reflected like this in down. So image is formed here finally. And you know anyhow the principle of a plane mirror. How much distance will be the object? Image will be also of the same distance. Object distance is equal to image distance. There Cassegrain is arranged here, a convex, and the image was observed. And here the convex lens is adjust here. So after coming the light rays, the image is formed there. So ఈ విధంగా ఏంటంటే న్యూటోనియన్ టెలిస్కోప్ ఉపయోగించి defects was minimal, completely we cannot eradicate spherical and chromatic aberrations, but it is minimized. Okay, so in this fashion Newtonian telescope, that is reflecting telescope, was explained by the scientist. Clear? So these two are very important. These two are very important for the numerical, not numericals of course. In the examination they may ask as a bit question, how many types of telescopes are there, name them. దీనికి సంబంధించి డెరివేషన్స్ ఎగ్జామినేషన్లో అడగరు, లేవు కూడా సిలబస్లో. క్లియర్? ఇన్ హయ్యర్ క్లాస్ వెన్ యూ గో in BSc level, whatever level, there you will be studying there. Okay, and this is the end of the ray optics and optical instruments part 7, and again we will be meeting in our next chapter, that is physical optics or wave optics. Okay, right.